Hello, welcome back. Today I thought we would work on exceptions in Natalie. We may not get all the way to real exceptions that you can raise and rescue in the language, but um, my minimum that I want to accomplish is rather than having assertions and abort all over our C code, I want it to uh, raise an exception internally, and then catch that at the top level and print the error. And I think we can get there. So we're basically going to be working from the inside out. We're not going to be working on the parser and going from the outside in, which is what I like to do normally. I think for this, I need to think more in the C code than normal. So I want to make sure it works before I do a whole bunch of other work around it. I don't think I've ever used setjmp and longjmp, which is the way I want to do this. In my previous compiler, the way I did exceptions was kind of gross. I made every function call return, or every function call would be called, and then it would check the return. If the return was an exception, then it wouldn't execute any code below that, and it would return, and it would just bubble up the call stack until it got to the root, or it got to a try catch kind of a thing. So this is going to be a lot different than that. So don't know really where to start, other than I've been looking at the Wikipedia page here for setjmp.h, and this example I think explains it all pretty well. You include this header, and then you can call setjmp anywhere you want. You pass in a jump buffer, and here they have it as a static global, but in our case, I believe we'll attach it to the environment so we can have lots of them. Um, Down the road, we'll have lots of them potentially, depending on how many begin rescue blocks you might have. But so it stores that in the buffer and does some stuff, and then it calls longjmp, which jumps back to this and returns a non-zero value. It returns a 1. So if by default setjmp returns a 0, and then whenever longjmp is called, it returns whatever the longjmp returned. So that's how we can do exceptions. The idea being that like the normal code is here, and then anywhere along the way you can raise an exception. In our C code, we're going to do a longjmp, and then the else here would basically be like the rescue. And we're just going to have one top level rescue for now, and we'll see how it goes. So not sure where to start exactly, other than maybe just some example code. No, do I want any example code? Yeah. So let's try that. Examples, exception. Oh, of course I misspelled that. And we're gonna do do I even need this? No, I don't even need this. Let's just do it here. So instead of this abort trap here, I'd like that to be a real exception that we can print better details for. So undefined method foo for object. So I know where that is, right? That's in Natalie C, undefined method. And in this case, it's this one here because it's a regular method, not a class method. And we essentially want to be able to call longjmp, right? Longjmp, and then pass in the buffer. So the code we want is something like this. What is this called? It's a jump buff. And then we want to be able to call this. So the way we get there is to back up a little farther, and we'll go to main C. And this eval is the sort of entry point into our code. for a compile binary and for the REPL in both ways. So I think I want to do it here. We're going to include that. Do I want it above? Yeah, I feel like it should be above. And we want to do essentially this, but it's going to be on the env and it's going to be jmp buff. And then we're going to run this code, and yeah, there is no jump buff on env. That's right, Natalie H. We're going to add that. env is going to have, it's going to have this. We're just going to call it the same as its type. It's not going to like that. Let's call it with jump spelled out, jump. Okay, and we also need to do the include here. And I'll sort these. Yeah, does it? It really doesn't like, I don't like the syntax highlighting, so I'm just going to spell it out here and spell it out here. Do I need to initialize the buffer anyway? No, don't need to initialize the buffer. It's going to run the code. This shouldn't break anything. I should still be able to. What do you mean there's nothing to make? I don't believe you. I feel like there should be something to make. Okay, so nothing broke. Let's see about Natalie C. I wish I could pass in like a nat object here instead of an integer. And we're just going to say there was an error. We don't know what the error is. It's just an error. Make. Okay, well, that's good. So that is working, and we could start sprinkling that throughout the place. But we need a place to store the exception when we do that. So the code I'd like to write is env exception equals nat exception env. Ruby exception classes. Let's just look these up. Exceptions, class hierarchy. That's what I want. The exception class is the top, and then there's standard error. I mean, there's a bunch. So in IRB, when I do this, what kind of error is that? That's a name error. And a name error is a standard error, and a standard error is an exception. So let's just make those. So do we need an exception type here? Value exception. And if it's an exception, it's going to have some stuff. Is it? Yeah, it definitely is eventually going to have some stuff. I don't know that we care right now what that stuff is. Message. Let's just do message for now. Later on, we might have line number and stuff like that. Okay, I did some more thinking about this and I looked at IRB to see what Ruby does, and Ruby doesn't seem to be storing the message in an instance variable. So it does seem like to me that Ruby is storing it kind of in that hidden place. So I want to do the same thing. I'm not sure why it needs to be that way. Just feels right. Sort of like we store symbols and strings and stuff like that. Um, yeah, I don't know if it's really necessary, but we're going to do that. So an exception stores its message here, and it's going to be, yeah, it's just going to be an exception value, sort of like a string or a symbol or something else. And we're going to do nat string. We're going to copy that. Nat symbol, nat array. We're just going to put it right here, nat exception, and we're going to call this message. And let's go back and look at our hierarchy again. So it's going to be standard error. I'm going to always make it a standard error by default. Standard error, nat value exception, don't care, don't care, don't care, message, message, and return the object. H. It's going to be close to here. I think I did it underneath symbol, didn't I? Yeah. Exception. And then we need to build the hierarchy here. Nat object exception equals nat subclass. Is it an object? I assume it's an object. Exception.new.class. Exception and the superclass of exception is object. Yeah. Object, and then we're going to call this exception. And we're going to say the type is nat value exception. When you do a subclass, does it copy the type? I think it does. Oh, no. It's always a class. Oh, it has to be a class. No, that's right. That's right. We don't actually want this. It is a class. And this is going to be standard. It's going to be standard error. Nat subclass, and this is going to be exception, and it's going to be standard error. I'm not going to build all of them right now, just the ones I need. And then the one I want is name error. Is that right? Name error, yep. Name error. It's going to be standard error, rename error. And we need to set all these. Exception, exception, standard error, standard error. Okay, something about this feels a little wrong. But hopefully that's right. Nat exception. Hmm. I wonder if I even want to do this. Yeah, we're going to do it like this. That way you can pass in the class and the message. Creates a new one. It sets the message, sets this. Yeah, I think I want to do it that way. Okay, let's just make sure we didn't break anything. Perfect, that still works. So in Natalie C, where we did long jump, what we want to do here is, oh, I didn't actually run make. That's going to fail. Yeah, that's good. We want to do name error, and we want to say, let's just do basically what they did here. Undefined local variable or method, and then you got these quotes, and I'm going to have to use SN printf probably. Is that SN printf, I believe? Yeah, so buffer size format string. I don't like this either. Going to use our own string class. Yeah, use our own string class. I'm going to say, oops, what is happening? Undefined local variable or method. Yep, for no, we don't have %s, of course not. Do we, I really want my own, I want string formatting. I think I did this in Mal, so I'm going to copy it. Don't know why this is being so slow. Come on. Okay, I don't need to go to GitHub. Mal s printf. Yes. I'm going to copy that. Not mal, nat string. We're just going to paste this here. If I can figure out what I pasted, what I copied, there we go. So it's going to be nat s printf. It's going to have the format and then a bunch of stuff after it. I believe for that we're going to need standard arg. Yep, got it. Okay. This is going to be a string env. We also need nat env here. Cool. String linked formats, variable argument stuff. Go through all the arguments. Get the format string. If the character is a %, then we get which letter it is. And we already have nat string append, right? STRS, perfect. Nat string append nat string, we don't have yet. I'm going to comment that out. Oh, this isn't auto formatted, is it? There we go. Break, yep. Do that. If it's an int, actually, I don't care about all of this right now. Come back and do it later. Out, that's been care, yep. And then let's do that. Unknown format. I'll just call abort here, make it uglier. Otherwise, we just append the character. Mal type, yeah. It's going to be nat object. It's going to return the object. What else are you complaining about here? Function definition is not allowed here. Function definition is not allowed here. What? What is this one complaining about? Not allowed here. Not allowed here. What? What have I done? Oh, I didn't finish wherever I was here. Yeah, I didn't actually finish this. So this is going to be nat string printf, right? What was it called? Nat s printf, yeah. S printf, environment, format, yep. So we'll just copy this. %s. And then these are going to be method name and instance class name. And that's the message. And pass the string of it here, do a long jump. Okay, now what are we unhappy about? No member named exception in nat env. No member named exception. Oh, right. I haven't done that yet. So let's copy this. Conflicting types, that's fine. Only H. We're going to put this here. And the environment's going to have an app object exception. Okay. Oh, I still have a mal type in Natalie C. Natalie C. This is nat object. Nat object, nat object. Perfect. Make was successful. Perfect. Foo, error foo. Okay, this is good. Main C. So rather than just print error here, we're going to get the exception. Object exception equals env exception. We're going to assert that that is a thing. Exception. And then we're going to say exception message here. Let's just go ahead and just for safety at value exception. Just to make sure that is the right thing. Oops, oh, that just worked. Undefined local variable or method foo for object. Oh, that's awesome. Cool. Okay, let's add that to our index. Because what I want to do is to make sure that it can bubble up. Because I think that if I do def foo bar and foo segmentation fault. Yes, because we're grabbing the exception off of here. At least I assume that's the reason. Oh, we got some warnings. I probably should fix that. Format string is not a string literal. Oh, yeah, I know you don't like that. Okay. That should work, right? Does that get rid of all our warnings? And we have one more. Local control may reach and where is that? 201 and Natalie C. May reach the end? No, that's not the right code. I wish it would tell me what it's complaining about. It, 201. Oh, no, that's right, main C. Okay, so if eval let's just make it return nil. I don't know if that's correct or not. At least we don't have the warning anymore. Looks like bad access. Oh, it's the long jump. That's the long jump it didn't like, which makes sense because, so I believe when I do build env, I need to copy the jump buffer because every child environment needs to have access to either its parent jump buffer or later on we might build, yeah, because when you do a begin block with a rescue, we'll build a new jump buffer. But by default, the env always gets the jump buffer of its outer jump buff. That's here. Yeah. Cool. Make. Didn't like that. Array type jump buff. It's not assignable. Oh, I have to copy it. I have to mem copy it? Nope. I'm not going to do that. That won't work. So we're going to make this a pointer. And then when we build the env, we're going to malloc it. Size of jump JMP buff. There's that. And then when we did long jump, this has to be that, I think, and C, and this is going to be dereferenced. Assertion failed, abort trap, blah, blah, blah. What is that complaining about? Assertion failed, exception. It's not an exception. It's good. So right here, this is the top level environment, but we're setting it on a nested environment. I'm setting the exception. Okay, pause for thinking time. Okay, I'm back. So in thinking this through, I think I always want to accept the exception at the top level environment. May not be the best solution down the road because I think in Ruby you can, I've seen this in bug snag errors at work where it remembers, like if you have an exception that's rescued and then another exception is raised, somehow it remembers the previous exception. It's storing that somewhere, don't know where. I think for our use, I'm just gonna pretend that is not a thing for now. So what I want to do here is I want to do set exception env and then put that here and then build some sort of function that walks up the environment hierarchy and sets it on the right one. Env set exception, yeah. Yeah, so it's gonna look something like this. Void env set exception, not env, not object exception, and it's going to say until env outer is null. I'm going to say env equals env outer. I'm going to say env exception equals exception. And we don't return anything. Natalie H. Oh, until while there's an outer, then walk up it. I don't know where I got it. Until, oh, Ruby, of course. This comes from Ruby. Make undefined local variable or method bar. Cool. And then this should work also. Undefined local variable or method foo. Yeah, that's working great. Add that to our index. Cool. So let's go replace all of our aborts with actual stuff like that. So long jump. Although I don't. Oh, let's not actually call long jump. Let's make it a little prettier, like we know what we're doing. We'll say nat raise env, and we'll set the exception here. So it's going to do these two things. void nat raise, nat env v, nat object exception. It's going to do this, and it's going to set the exception, and that's going to do a long jump. Yep, and I want to put it up here. Okay, so now let's make sure that works. Yep, perfect. So now when we want to raise an error, we can do this. Let's look for abort. Say undefined local variable or method S for receiver class name, this symbol. I'm gonna do that, and no more aborts. Let's look for our asserts. This is instance variable getting, so what? Natalie C 316. What are you upset about? Oh, I wonder. Yeah, I'm gonna get warnings all over the place if I don't return something, right? Maybe I should just be able to do return here, and it returns the exception, even though it's not ever going to really return. I think it would look nicer. And it would make all the warnings go away. So let's do it that way. Nat raise, we're gonna return it. Yeah, I think I like that. Perfect. Foo works. Class, let's just do at var. That should be an error, right? Well, that's a different bug. Yeah, broke something. I don't know when we broke that. Is that a known issue? Well, nuts. String inspect. Method.nat. I didn't expect that at all. So, let's just see where did they start breaking? It still works? No, it doesn't work. Nat string.c. Huh. Not sure what we broke. And by we, I mean me. I. Run, give me a backtrace. Whoa. Okay, that's fine. Call method on class, print, not send, call method on class, string inspect. What did I change? Okay, set jump, just some exceptions and stuff. Wrapped that in a set jump and if else. That shouldn't have done it. Standard arg, jump buff, outer jump buff. Yep. env set exception. Just making sure this, that looks normal, looks right. That exception, this creates an exception. Nat s printf env undefined local variable or method %s for %s. We pass in the symbol, pass in the receiver class name, and then we do an exception. We raise it. Similar for this one. All that looks good. Nat s printf. Set jump had to go here. Object exception, nat value exception. Oh, that looks fine. It was, yes. Okay, well, let's just go digging. LLDB run, backtrace. I want to get to frame 4. And man, I hate LLDB. I do not know how to use this. Where's my string inspect? Okay, so I assume it's this one that's failing. Self, p self. I declared identifier self. Am I not in frame 4? Backtrace. Yeah, I'm in frame 4. String inspect. Can you not, in LLDB, can you not just print the arguments? Prints should be self, env, self. Piece of junk. And I don't think I have GDB working on here. Run. Yeah, does not like that. Okay, fine, doing it the hard way. What are you complaining about? Type equals 9. Type equals 9. That's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It is a string. Nat value string. What do you want from me? Okay, I'm back. I figured it out, although I didn't really figure it out. I ran make clean, ran make again, and now all the tests are passing. Oops. Ah, that's so frustrating. It is an object file that didn't get rebuilt. Maybe, I mean, my only thought is once I changed this header file, I added stuff to it, and I changed the order of these, I should have rebuilt all the object files. So yeah, rookie mistake. Spent, 20, 30 minutes tracking that down. But I think everything's good here. We still have the error. Well, we still have that problem, but that's a different problem. We should now be able to do foo.new.foo, which should cause an error. Undefined local variable or method bar. Undefined local variable or method foo. So we can get back to looking at all of our asserts. And we can raise exception. Net raise. There's one. Okay, we can look for assert. Not all of our asserts are going to be turned into exceptions. Some of them are just internal. Since variable get foo. Yeah, so I think I have that in Natalie also. Since variable get foo. Yeah, so that should raise an exception. So the message is going to be something like that. It's going to be a name error also. That's handy. So it's going to be s is not allowed an instance variable name. Perfect. And this is going to be name. So that's the message. We're going to raise a name error with that. I kind of wonder if I should shorten that. I think I should. So I'd like to do return nat raise. Oh, there's got to be an if. If it's not that. There we go. So let's just copy that. Any more assert that we want to turn into errors? This one also. So if I do make, oh, I should not return value 97. Okay, that was too much copy paste. And this one should, yep, awesome. Set one that should, this is variable name, perfect. And let's see, let's just do one more just for good measure. So nat object, see any assertions in here. nat array C, the assertions in here. These are fine. So all of these argument count ones, I'd like to turn, I'll do that probably outside the video, but I'd like to turn these into exceptions. So say if it's not, I'll just do 1 as an example here. What happens if you do IRB def foo takes an argument and you do foo with no arguments, you give it an argument error. So here, I'd like to do this. I assume an argument error superclass is standard error. Yep. So it's going to look like this. Argument error, standard error, argument error, argument error, argument error. So now we can do that here. That's an argument error. The message is wrong number of arguments given expected, given arg count expected 1. Yeah, oops, I don't know, we'll see. Array is this, we're going to try to add 1 to it. That should work. Let's try to add 2. And then format specifier D. Okay, fine. Yeah, because I commented that out. But let's do I. Let's make us abort I. We're going to append. We're already doing that in integer, right? Converting it to a string, int to string. I already have that. Perfect. Int to string. And it just takes a number, va arg ap int. It's been a while since I've done this. I hope that's right. Oh, it still doesn't like D. This can be a D, that's fine. Oh, I thought, oh, no, that's the Ruby way. Case. Wrong number of arguments given to expect 1. Ha, that's cool. Okay, I want to do that all over the place. I won't do it in a video because it's going to be super boring. But this is so cool. So now we have exceptions, at least the concept of them, and maybe in the next video I can do begin and raise blocks, begin, rescue block, and raise, and all that stuff, so that the exceptions can actually be exposed in the language. And wow, this is cool. Thanks for watching. Sorry that was kind of long. Like I said, I want to try to cut that down so you don't have to watch me puzzle, hurt my brain so much, puzzle these things through. But that's it. So thanks for watching. I'll see you next time.